What if you're working with seasonal data, and let's say it's third quarter, and you're planning to make a forecast for fourth quarter? What if the best guess of what's going to happen in fourth quarter is simply what happened fourth quarter last year? Or what if the best guess of what's going to happen in fourth quarter is an exponentially smooth average of what's happened in fourth quarter of last year and the year before that, and so forth? And suppose that's true for all of the quarters. Is there an ARIMA model to handle that situation? Yes, there is. It's really simple, and we're going to quickly talk about that particular model. So let's suppose we're looking at some seasonal data, and let's pretend for just a moment we took out all of the months of January across several years, and we just did an exponential smoothing model to predict what's going to happen on the next January. And we did the same for February and March and so forth. That would be an ARIMA 011 sub S model. In this case, S would be 12. You could do the same thing with quarters or whatever. A special case of that would be the random walk version of that, where you simply say, my forecast of what's going to happen next January is last January, and the forecast of what's going to happen next February is last February, and so forth. Here's the good news. You're not going to have to learn two new models. You're not going to have to develop a new spreadsheet. You're not going to have to have some way of identifying that the two models that we just discussed are the appropriate models. You already have everything you need to be able to do that. So let's take the spreadsheet or the model that we worked with last time, and let's pretend when you do solver and find the optimal values of alpha and beta, alpha comes out to be 0. Or it comes out to be very close to 0. For example, it could be minus 0.001 or whatever. When you do that, and it says there's no additional information gained by changing the level of the process, it just stays the same all the time, which really means the level is not participating in the forecast at all, because it's not changing. So that means you could use one of the two simple models that we just talked about, where to forecast what's going to happen next quarter. I'll just go back and look and see what happened in that same quarter last year. So to repeat what I just said, the level of the process is not changing when alpha is near 0. There's no additional information gained by updating the level over time, apparently, because that's what the model has just told you. And the forecast is only using the seasonal information. In other words, ignore the level of the process and just use the same quarters of previous years to get the forecast. And then to get to the model that you just need to make two simple changes in your spreadsheet. You first would fix alpha at 0, and then the initial level, which is ordinarily set to whatever's in that very first quarter or first month or whatever, just set it to 0. And then from then on, the level stays at 0. Now, look what has happened when we set alpha at 0 and we set the level at 0. Look at the column that says dollar sales. That's your raw numbers. That's your original time series. Now look at the column that is labeled D sub T. Before, those were discrepancies, but now they're discrepancies from a level of 0. So D sub T is the exact same as the column that says dollar sales. So the data that we now have in column T is just the raw data. And if you wanted to be a perfectionist, you could go back and type in that first period there, but that's usually not necessary. And now that we have actual values in the column D sub T, the next column, S sub T, is exponential smooth values of those actual values, except they're smooth across years. In other words, the exponential smooth value for first quarter is smooth across the years, and then the second quarter, and then the third quarter, and the fourth quarter. So now you've done what we talked about earlier. If you look at, say, the very bottom row there, the fourth quarter, that S sub t of 4199.0012 is an exponentially smooth value of the fourth quarter of this year and the fourth quarter of the previous year. And the forecast is simply the smooth value from 3 quarters earlier. In other words, let's suppose we're in first quarter of the second year there. We're going to forecast into second quarter. All we do is go back into the second quarter of the previous year and pick up that value, and that becomes our forecast. And that arrow passes right through those two numbers. The forecast that we make in first quarter, which is a forecast for second quarter of the second year, is the smooth value of the second quarter of the first year. Even though I talked about what was happening to the D sub t's and the S sub t's and the forecast and all of that, you only had to change those two cells, the value of alpha and that initial value of the level, and everything else happened automatically. You change two cells, and now you automatically have this new model. And now the only thing to do is to optimize beta, and you've got your model. So to state mathematically real quickly what we're doing is the formula on the top would be how you would ordinarily see the ARIMA0 1 sub 4 model, or and it just says you smooth your data by going back 4 periods. You use last year's smooth value and this year's observed value to update your exponential smoothing. And what we just saw, if we take our spreadsheet and we set alpha equal to 0 and set the level equal to 0, you get the same result automatically, except you're smoothing the column that we call D sub t, but now D sub t really just contains the actual values. And then the forecast is just go back 3 periods and pick up that smooth value. In our spreadsheet, we add the level plus that smooth value from 3 periods ago, but now our level is 0, so we get the same result. And if when we optimize beta, it turns out to be fairly close to 1, we would go ahead and test the standard error we get by fixing beta equal to 1. And if we get pretty much the same standard error, we would just fix beta at 1, and now our forecast is simply the forecast for this quarter is what we observed in this same quarter last year. That's the random walk version of the model, and we call that the ARIMA0 1 sub 4 model. And here are the verbal descriptions of those two models. I think you've pretty much got them in your head now, but in one case we're just forecasting using the same period last year, and the other case we're exponentially smoothing that same period from all previous years.